When you look up at Jupiter in the night sky, it appears as a serene, golden point of light, steady and quiet. Through a telescope, it looks like a masterpiece, wrapped in soft pastel bands of cream, amber, and deep rust, anchored by the iconic Great Red Spot. It feels majestic, ancient, and calm. That serenity is a lie. If you could strip away the distance and descend toward Jupiter, you would not find a world, you would find a monster. Jupiter is not a planet in any sense that human intuition understands. It is no solid ground to stand on, no gentle breeze, no friendly horizon. Instead, it is an engine of pure cosmic violence, a world-sized abyss of crushingly heavy atmosphere, ocean-like depths of liquid metal, radiation belts that can fry heavy machinery in seconds, and storms that could swallow the Earth whole without even noticing. Jupiter is the oldest planet in our solar system, and in many ways, it is the master of it. It holds more than twice the mass of all the other planets, moons, and asteroids combined. If you brought all those other worlds together into a single giant sphere, Jupiter would still dwarf them easily. Because of that unimaginable mass, Jupiter dominates everything around it. It pulls on asteroids, alters the orbits of comets, and shapes the fate of every object in the solar system, including our own home. We tend to think of space as cold and quiet, but Jupiter is loud, relentless, and deeply terrifying. To understand Jupiter is to realize how fragile Earth truly is and how close we live to forces capable of total destruction. To begin to understand this monster, you have to start with its size. If Earth were the size of a marble, Jupiter would be the size of a basketball. You could fit more than 1,300 Earths inside Jupiter's volume. If you dropped Earth into the Great Red Spot, Jupiter's most famous storm, our entire planet would sink into that crimson vortex with room to spare. Yet despite its colossal size, Jupiter rotates at a speed that defies logic. A single day on Earth lasts 24 hours. A day on Jupiter, one full rotation of a world 11 times wider than Earth, lasts less than 10 hours. Think about what that means. To complete a spin in under 10 hours, Jupiter's equator must move at roughly 28,000 miles per hour. Earth's equator moves at a comparatively sluggish 1,000 miles per hour. This hyperrotation reshapes Jupiter physically. It bulges out at the equator and flattens at the poles, straining against its own immense momentum. More importantly, this rapid spin acts as an engine that churns Jupiter's upper atmosphere into a perpetual war zone. When you look at the famous stripes across Jupiter, you are not looking at static features. You are looking at giant planetary jet streams ripping past one another in opposite directions at hundreds of miles per hour. The light-colored bands, known as zones, are regions where warm gas is rising from the depths. The darker bands, called belts, are where cooler gas is sinking back down. Where these oppositely directed jet streams slide past each other, the shear friction creates violent shear forces. The atmosphere buckles, twists, and tears itself apart, spinning up vortices, eddies, and storms that can last for days, years, or centuries. Earthly storms are driven by solar energy. The sun warms our oceans and atmosphere, driving weather patterns, but Jupiter is 5 times farther from the sun than Earth is. It receives only about 4% of the sunlight we do. Yet, Jupiter's weather is infinitely more violent than anything Earth has ever experienced. Why? Because Jupiter generates its own internal heat. Deep inside Jupiter, heat left over from its formation 4.5 billion years ago, combined with heat generated by the continuous gravitational compression of its immense weight, is slowly escaping outward. Jupiter actually radiates more energy into space than it receives from the sun. It is powered from within. This thermal engine drives updrafts of warm gas from thousands of miles deep. As that heat rises to the frigid upper cloud decks, it collides with the freezing cold of space. The temperature difference, combined with the planet's ferocious rotation, unleashes weather on a scale that borders on the nightmarish. Lightning on Earth is a brief electric spark. On Jupiter, lightning strikes are thousands of times more powerful than anything seen on Earth. These are superbolts, flashing deep within clouds made not just of water but of toxic ammonia and ammonium hydrosulfide. They illuminate storm clouds that tower dozens of miles high, casting eerie, flickering glows across atmospheric abysses that have no floor. And then, there is the Great Red Spot. Human beings have been watching the Great Red Spot through telescopes for over 350 years. It is an anticyclone, a high-pressure storm system, spinning counterclockwise in Jupiter's southern hemisphere. It is whiter than the Earth. The winds at its outer edges scream at over 400 miles per hour, far exceeding the strength of the most powerful Category 5 hurricane ever recorded on Earth. We do not fully understand why the Great Red Spot has survived for centuries while earthly hurricanes dissipate in a matter of days or weeks. On Earth, a hurricane eventually hits land. The friction of the ground drains the storm's kinetic energy, breaking it apart. But Jupiter has no land. There is no solid surface to grind a storm down. The Great Red Spot simply rolls on, feeding on smaller storms, absorbing them and drawing energy from the deep internal heat of the planet. Yet, as terrifying as the atmosphere looks from the outside, the true horror of Jupiter begins when you try to imagine diving into it. Imagine dropping an atmospheric probe into Jupiter's cloud tops. At first, things might seem almost familiar, if alien. You fall through thin clouds of white ammonia ice where the temperature is a freezing -200 degrees Fahrenheit. The pressure here is similar to the air pressure at Earth's surface. Sunlight is pale but present. As you fall deeper, the light begins to dim. Within a few dozen miles, you drop through a second layer of cloud decks, murky orange-brown clouds made of ammonium hydrosulfide. The sky above you fades from a pale, tawny hue to a dark, menacing brown. The temperature begins to rise, driven by the intense pressure building above you. By the time you reach 60 miles down, you pass into thick clouds of water, ice, and vapor. It is pitch black now. Sunlight cannot reach this far. The only illumination comes from the catastrophic flashes of super lightning tearing through the dark clouds around you. The wind here is unrelenting, howling at hundreds of miles per hour, tossing you through turbulent updrafts and violent downbursts. But wind is soon the least of your concerns. The true killer on Jupiter is gravity and pressure. On Earth, air pressure is caused by the weight of the atmosphere above us pressing down. At sea level, that pressure is about 14.7 pounds per square inch, or 1 atmosphere. If you dive into Earth's oceans, every 33 feet of water adds another atmosphere of pressure. At the bottom of the Mariana Trench, 6 miles beneath the ocean's surface, the pressure is about 1,000 times greater than at sea level, enough to crush an unprotected human instantly. On Jupiter, as you descend past the cloud decks, there is no ocean floor to stop you. There is only more atmosphere. At a depth of a few hundred miles, the pressure reaches hundreds of atmospheres. The temperature climbs past the boiling point of water. The gas around you is no longer just air. It is becoming so densely packed that the boundary between gas and liquid begins to blur. Scientists call this state a supercritical fluid. It is a strange, exotic phase of matter where a substance has the density of a liquid but flows like a gas. You are no longer falling through air, nor are you swimming through water. You are sinking through a dense, hot, suffocating mist that grows thicker with every mile. If your probe were built to withstand temperatures of thousands of degrees and pressures thousands of times greater than Earth's sea level, it would keep falling. At a depth of roughly 15,000 miles, about 2/3 of the way to the center, the environment transitions into something that sounds like science fiction. Here, the pressure reaches several million times Earth's atmospheric pressure. The temperature soars to over 15,000 degrees Fahrenheit, hotter than the surface of the sun. Under these apocalyptic conditions, hydrogen, the simplest and most abundant element in the universe, which exists on Earth as a light, invisible gas, is crushed so violently that its very atomic structure breaks down. Normally, a hydrogen atom consists of a single proton orbited by a single electron. The electron is bound to the proton. But when you squeeze hydrogen atoms together under millions of atmospheres of pressure, the atoms are forced so close that their electron shells overlap. The electrons are ripped free from their host protons. They begin to flow freely from atom to atom, forming a churning ocean of unbound subatomic particles. Hydrogen has become a metal. This is liquid metallic hydrogen. It does not exist naturally anywhere on Earth. We have only managed to create microscopic traces of it in advanced physics laboratories for fractions of a second using laser-driven shockwaves and diamond anvil cells. But inside Jupiter, liquid metallic hydrogen forms a vast global ocean tens of thousands of miles deep. It is a glowing sea of liquid element that conducts electricity and heat with incredible efficiency. If you were to drop further into this liquid metal ocean, the pressure would continue to climb to tens of millions of atmospheres, and temperatures would rise toward 30,000 degrees. At Jupiter's center, scientists believe there may be a dense core made of heavy elements, rock, ice, and metal, compressed by the weight of an entire world. For a long time, planetary scientists assumed Jupiter had a sharp, solid, rocky core at its center, perhaps 10 or 20 times the mass of Earth. But data from NASA's Juno spacecraft, which arrived at Jupiter in 2016, revealed a stunning and unsettling surprise. Jupiter's core is not a neat, solid sphere of rock. It is a fuzzy, diluted, partially dissolved core. The intense heat and unimaginable pressure deep inside Jupiter have caused the heavy elements of the core to dissolve into the surrounding liquid metallic hydrogen. It is a slushy mix of rock, iron, and metallic hydrogen spreading across thousands of miles. How did a planetary core become dissolved? The leading theory is staggering. Early in the history of the solar system, roughly 4.5 billion years ago, when planets were still forming from a chaotic disk of dust and debris, a colossal protoplanet, perhaps 10 times the mass of Earth, may have collided head-on with Jupiter. The impact was so violent that the incoming world plunged straight through Jupiter's outer layers and smashed directly into its primordial core. The energy of that collision shattered the core, mixing its heavy rock and metal into the surrounding hydrogen ocean. 4 billion years later, Jupiter has still not fully recovered from that impact. Its center remains a chaotic, semi-liquid slurry. This vast ocean of liquid metallic hydrogen does something else, something that makes Jupiter even more dangerous to anything that approaches it. Because metallic hydrogen is filled with free-flowing electrons, and because Jupiter spins at such a dizzying speed, the movement of this liquid metal ocean generates a magnetic field. Not just a normal planetary magnetic field like Earth's, a magnetic monster. Jupiter's magnetic field is the largest continuous structure in the solar system, short of the heliosphere created by the Sun itself. If Jupiter's magnetic field were visible to the human eye from Earth, it would appear in our night sky twice as large as the full moon, despite being hundreds of millions of miles away. At its source, Jupiter's magnetic field is 20,000 times stronger than Earth's. Earth's magnetic field is a gentle shield. It deflects harmful solar radiation and creates the soft, shimmering auroras near our poles. Jupiter's magnetic field, by contrast, is a particle accelerator of cosmic proportions. As Jupiter rotates, its magnetic field sweeps through space, trapping charged particles, electrons, and ions that stream from the Sun or are spewed out by Jupiter's volcanic moon, Io. Io is a world torn apart by Jupiter's immense gravity, covered in hundreds of active volcanoes that launch tons of sulfur dioxide gas into space every second. Jupiter's magnetic field catches this volcanic gas, strips its electrons away, and accelerates the charged particles to nearly the speed of light. These ultra-high-energy particles are trapped in massive, donut-shaped radiation belts surrounding the planet. To stand inside Jupiter's inner radiation belts would mean receiving a lethal dose of radiation in a matter of minutes. The radiation is so intense that it degrades electronics, fries silicon microchips, and breaks down structural materials. When NASA sent the Juno spacecraft to study Jupiter, engineers had to enclose the ship's sensitive electronic brains inside a titanium vault weighing nearly 500 pounds. Even with that heavy armor, the radiation slowly degrades the spacecraft's instruments over time. Jupiter systematically destroys the human technology sent to observe it. This electromagnetic trap reaches far beyond the planet itself, creating a bizarre and terrifying dynamic with Jupiter's closest moons. Take Io, for instance. As Io orbits Jupiter through its intense magnetic field, the moon acts like a giant electric generator. It cuts through Jupiter's magnetic field lines, driving a continuous electric current of millions of amperes between Io and Jupiter's upper atmosphere. This massive electric circuit discharges at Jupiter's poles, creating powerful auroras that crackle with gigawatts of power. These are not soft curtains of light like Earth's northern lights. They are roaring, violent electromagnetic storms that blast high-energy radio waves across the solar system. If you listen to Jupiter with a radio telescope, you would not hear silence. You would hear a loud, eerie, whistling roar, a planetary broadcast generated by electrons spiraling down magnetic field lines into Jupiter's atmosphere. Jupiter is loud. It is dangerous. It is actively hostile to life as we know it. And yet, here is the ultimate paradox of Jupiter. The very same properties that make Jupiter terrifying are the reason Earth exists in a state that allowed human life to evolve. Because of its massive weight and powerful gravity, Jupiter acts as a gravitational shield for the inner solar system. For billions of years, Jupiter has been clearing the outer solar system of dangerous debris. When icy comets and rocky asteroids sweep inward from the cold edges of the solar system, Jupiter's immense gravity acts like a giant cosmic vacuum cleaner or a gravitational slingshot. It either absorbs the impact itself or flings the comets safely out of the solar system altogether. We saw this happen in real time in July of 1994. A comet named Shoemaker-Levy 9 was captured by Jupiter's gravity. As the comet drew close, Jupiter's intense tidal forces tore the icy world into more than 20 distinct fragments, stringing them out like a necklace of cosmic fire. One by one, those fragments slammed into Jupiter's southern atmosphere at speeds exceeding 130,000 miles per hour. The explosions were catastrophic. The largest fragment struck Jupiter with a force of 6 million megatons of TNT, hundreds of thousands of times more powerful than the world's combined nuclear arsenals. The impact blasted plumes of hot gas thousands of miles above the cloud tops and left dark, bruised scars in Jupiter's atmosphere that were larger than the entire planet Earth. Those scars remained visible for months. If comet Shoemaker-Levy 9 had struck Earth instead, it would have caused a global extinction event far worse than the impact that wiped out the dinosaurs. It would have vaporized oceans, set the atmosphere on fire, and ended complex life on our world. Instead, Jupiter took a hit for us. Jupiter has been taking those hits for 4.5 billion years. Without Jupiter sitting in the outer solar system like a massive guard dog, the rate of asteroid and comet impacts on Earth might have been dozens or hundreds of times higher throughout history. Life on Earth might never have had the millions of years of uninterrupted calm necessary to evolve from simple cells into complex, intelligent beings. Jupiter protects us by being a terrifying giant. Yet, scientists have begun to realize that Jupiter's role in our existence is even more complex and perhaps even stranger than simply acting as a shield. Dynamic computer simulations of the early solar system suggest that Jupiter may have once tried to destroy Earth before Earth was even fully born. In the earliest days of our solar system, when the sun was young, Jupiter did not form where it sits today. It formed farther out, where water ice could condense. But as Jupiter grew in mass, interacting with the thick disk of gas surrounding the young sun, it began to drift inward. This proposed event is known to planetary scientists as the Grand Tack hypothesis. As Jupiter migrated inward toward the sun, its massive gravity acted like a wrecking ball. It plowed through the inner solar system, sweeping up early protoplanets, smashing them into one another, and hurling their shattered remains into the sun. Jupiter was spiraling inward, destroying everything in its path on a trajectory that might have turned our solar system into a place with close-in super-Earths, or even swallowed the rocky building blocks of our planet entirely. So why are we here? Because another giant intervened. As Jupiter was migrating inward, Saturn, the second largest planet, was also forming and growing massive. Saturn began to migrate inward as well, moving faster than Jupiter. Eventually, Saturn caught up to Jupiter. The two giant worlds fell into an orbital resonance, a gravitational synchronization where for every 3 orbits Jupiter made around the Sun, Saturn made 2. When their orbits locked together, their combined gravitational influence cleared a massive gap in the surrounding gas disk. The gravitational forces reversed. Instead of migrating inward toward the Sun, Jupiter and Saturn turned around and migrated back outward, pulling away from the inner solar system and settling into the orbits they occupy today. Saturn saved the inner solar system. It yanked Jupiter back just in time, leaving behind a cleared ring of rocky debris near the Sun, debris that would eventually coalesce to form Mercury, Venus, Mars, and Earth. We owe our very existence to a delicate gravitational dance between two gas giants billions of years ago. When you step back and look at Jupiter through this lens, the planet changes. It is no longer just a cold, violent world of radiation and crushing storms. It is a fundamental architect of reality as we know it. It is a reminder that the calm, predictable order we enjoy on Earth is built on top of chaotic, terrifying cosmic forces that happen to balance out just right. Jupiter sits in the dark like a silent guardian, a world with no surface, a storm that never ends, an ocean of liquid metal, and a magnetic field that screams into the void. It is terrifying because it shows us what the universe is capable of when life is not part of the equation. Nature does not care about gentle temperatures, breathable air, or solid ground. Nature, on a cosmic scale, is extreme, indifferent, and violently powerful. Yet, Without that indifferent monster sitting out there in the dark, watching over the inner solar system, there would be no quiet blue world for us to stand on. There would be no atmosphere to protect us, no oceans to cradle life, and no human eyes to look up into the night sky and wonder. Jupiter reminds us of how small we are, how violent the cosmos can be, and how impossibly lucky we are to exist on this fragile oasis of calm we call home. So the next time you look up at that bright, steady light in the evening sky, remember what is actually out there. You are staring at a world of crushing depths, metallic seas, and eternal storms. A world that could destroy us in an instant, but chose through the cold laws of physics to make our existence possible instead.